Well, hey everyone. Today we're going to continue to dive into this awesome world of division, but today we're going to be looking at division in terms of skip counting, just another strategy we can use to help us as we multiply and get larger numbers. This, of course, is still using the idea of what we talked about before in the inverse of loops and groups. So we are going to be still using this strategy of loops and groups. If you're unsure of that, you can definitely use this video to learn that as well, or go back and take a look at the previous videos where we talk about this skill. And again, thinking about how we're using the inverse. So we're using the opposite, right? We know that if we know multiplication facts, then we automatically know division facts. So we can actually use multiplication to help us solve division, which then again takes us right back to skip counting, because that's what multiplication is. It's just very fancy skip counting. So let's kind of dive into this work today and kind of talk about it. I am going to do a quick loops and groups review, since we are going to be using that strategy today. So remember, as we think about how we divide, right, the whole concept of division, for example, if I had a problem like this, 20 divided by 4, the whole concept of that is that I'm taking 20 and I'm cutting it or dividing it or partitioning it. These are all kind of words you'll hear in division, into groups of 4. So my loops and groups means, oh, cool, I'm going to make 4 groups. And then I'm going to distribute this 20 into the groups, right? It's like I have 20 people and I need to put them into 4 teams. So I'm going to put one player here, one player here, 2, 3, and 4, right? And again, division is equal groups. And so that's why I'm doing one at a time. Each team gets one person. That's fair. That's equal. But that's not 20 yet, right? That's only 4. So I'm going to go 5, 6, 7, 8. So again, my groups are still equal, but that's only 8. And I have 20 people, right? Or 20 things, however you want to look at it. 9, 10, 11, 12, right? Still not there. So 13, 14, 15, 16, 17, 18, 19, and 20. And what I can see from this is that when we take our 20 and we create 4 groups, we get 5 people in each group. And that's what the equal grouping is. 20 divided by 4 equals 5, which again, if we thought about the inverse, if we did that opposite, it's true. If we look at this model, we have 4 groups with 5 in each group, which equals a grand total of 20. And there's our inverse, our opposite. 20 divided by 4 equals 5. 5 times 4 equals 20, right? It is the opposite. They mean the same things. They're just reversed. So that is loops and groups. That's what we've been doing. Now, the reason I want to talk about then skip counting today is that, well, things will start to change. Like we've been pretty lucky. We've been pretty lucky with the numbers we have to distribute, right? And counting by ones has worked. But all of a sudden, let's say a problem like this comes along where I have 64 divided by 2. Okay, so yeah, same system, right? In theory, I'll make 2 groups. But now if I really think about this, I'm at 64. And so if I kind of go like one at a time, I'm going to be here a while, right? It's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And as I rush, I make mistakes like this, right? Where my tally marks get close to each other and I don't do them clear, or I lose count and I make mistakes. And I think with larger numbers, counting by ones, it's just not efficient. And we talk about that word all the time in math. It will work. It's just not efficient. It's just not really going to get me to what I need accurately. So this is where skip counting can be really helpful. I think about the idea that really, even when we count by ones, that is skip counting. It's just, we're not really skipping anything. We're just counting by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But we also do know how to skip count by lots of other numbers. And there are some that are very compatible with us, numbers that we like to skip count by easily. For example, 2s, right? That's something we can skip count by pretty quickly. 2, 4, 6, 8, 10, 12, right? 2s are pretty sweet. Skip counting by 5s. That's another process. Oops, sorry, hold on, just wanted to get some space. That's another process that I can skip count by quickly. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, right? Like it's so much easier. In fact, I even counted faster than I could write on that to count by fives. And then also, I think another one is tens. Oh, stick that over here, right? 10, 20, 30, 40, 50, 60, 70. I mean, we can get to 100 pretty quickly when we count by tens. So why I'm bringing this up, this idea of skip counting, is that instead of sitting here and counting by ones, maybe I want to start skip counting by larger groups so I can get to 64 a lot quicker. So let me now really model that, because I know that was a lot of talking about it. So let's see. I guess, you know what? I'll start with tens. So what I'm going to do is I'm going to skip count by tens. Now, instead of going like 1, 2, 3, 4, 5, 6, you know, and putting it all in there, I'm literally just going to write the number down. So there's 10. That's a group of 10. 10, 20. Wow. Okay. So I already got rid of 20 and I didn't have to sit here and do a bunch of tally marks. But it's only 20. I'm trying to get to 64. So you know what? I'm going to do another group of 10. So I'm going to put a plus sign in here so I realize that I'm going to be adding these groups together, right? So 10, 20, 30, 40, okay, 50, 60. Well, look at that. We're already at 60, and I just did 3 groups of 10. Okay, so doing another round of 10 isn't going to work because that'll get me to 70, and that'll be too much. So I'm at 60. So I'm just going to go back to ones. So 61, 62, 63, 64. Well, now I got to 64. Notice how I did that. I did that by doing big groups of 10 first. And now instead of counting tally marks, I can just add up what I have in here. I have 10 plus 10. So that's 10, 20, 30, 31, 32. And so 64 divided by 2 is 32. So you can see skip counting by 2s or 5s or 10s. Again, those are numbers that we like to skip count by. We're compatible with those. I can take out larger groups right away to help myself get my answer, get my quotient. So let's try another one. Let's play around with that and like really put this to practice again. And again, if this is already making sense as I write this down, you know, remember, you can definitely pause the video, go do the work, and then come back and compare, right? Like do it before me and see if it works. So here's a good example, because now it's like 135. Like that's a lot. That's big. And again, if I was to sit here and count by, sorry, hit the wrong button. Oh, where is it? Oh no. Hey, here it is. Boy, that was a fun moment in our video. Hey, April Fools. Okay, so as I was saying, now, if we're taking 135 and we're going to count by ones, it's going to take us a long time to get there. So I'm going to use the concept of loops and groups, but I'm also going to skip count. So first I'm going to make my 9 circles. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, now this is what I mean. I'm going to do some skip counting instead. And let's see, actually, maybe I will make this smaller to give myself space. So let's scoot this up like this. Hopefully I don't make another error in making the screen disappear. Okay, so 135 divided by 9. And again, I think about, can I skip count by 2s or 5s or 10s? And so I'm going to start with 10s because I feel like that's going to go pretty quickly. So 10, notice again, I'm just writing in the number this time. I'm not doing tally marks. So 10, 20, 30. I think my pen is just coming to the end, just having a hard time writing on the screen. So 10, 20, 30, 40, 50, 60, 70, 80, 90. Wow, I'm already at 90. Okay, let's see here. If I do another group of 10, that's going to be too much, right? Because that would be what, 90, 100, 110, 120, 130. There's no way it's going to work. Okay, so I'm not going to do another group of 10, but I could go back to my other ideas. Like I just skip counted by 10s. Well, what if we tried to skip count by 5? Let's see if that works. So I'm at 90, 95, 100, 105, 110, 115, 120, 125, 130, 135. Oh man, I love it when it works that well. And there we have it. Like, look at what we got here. 10 plus 5 in each group is 15. And that's exactly what I get here. 135 divided by 9 gets me 15. And again, I was able to use skip counting as a way to help me take larger amounts to put in my groups. Same amounts, right? Because I'm keeping it equal. But this is also a much more efficient way to get there. So let's just do one more. I'm going to do this one pretty quick for the sake of time. I just feel like after making the screen disappear and everything, that got confusing. So I don't want to break the flow. So let's say we have 52 and we're going to divide it by 4. Okay, so again, I'm going to use loops and groups. So I'm going to make 4 circles. 1, 2, 3, 4. But I'm going to remember that I can skip count by 2s. I can skip count by 5s, or I can skip count by 10s to help me do this quicker, help me get to 52 quicker. So let's see, I'm going to go with 5s. So let's see, 5, 10, 15, 20. Okay, 25, 30, 35, 40. Let's see, 45, 50, 55. Okay, so that's not going to work there. So I'm at 40. So maybe I'll start counting by 2s now. So that's 40, 42, 44, 46, 48, 49, 50, 51, 52. So you see there, I actually did some skip counting by 5s. I did some skip counting by 2s and skip counting by 1s. Again, every time giving the same amount to each circle. That's the equal groups part of it. And then let's just look at what we got. We have 5, 10, 12, 13. So 52 divided by 4 is 13. Okay, so keep this in mind, practice this out. I think it's a really good technique to realize that now I no longer have to count by 1s as my numbers get larger. I can start taking or giving, however you want to look at it, larger groups into my circles to help me get to that number that I want quicker, right? Again, the idea of efficiency of math, doing something that I want to say it's easier. It's just the pathway is almost, it feels better, right? It makes more sense to go this way because why would I count forever when I can just count in larger groups and be quicker with it? So as always, thanks for your hard work, and we will see you next time as we take on some more division.